x-coordinate and a y-coordinate. This refers to the x-axis and the y-axis. We can then plot that point. This is along 1 on the x-axis and up 2 on the y-axis. We can plot it as such. And we do that for all 4 quadrants. What are the quadrants' names? Which one is quadrant 1?
Top right.
Top right. The one that both things are positive in. So this is the first quadrant. What is the second quadrant? This one?
No, to the left.
Yeah, this one. The second, so it goes anti-clockwise, third and fourth quadrant when it says what quadrants a point is in or something like that. Okay. We can also then do this in reverse. We can, if we have a point plotted, can we get the coordinates of that? We would look at the x-coordinate first. This lines up with 3 on the x-axis, and the y-coordinate lines up with -2. So we have the point 3, -2. Okay. Moving swiftly along to how do we get distances between points. There's 2 ways we can do it. We can do it using Pythagoras' theorem. Let's look at these 2 points in particular. We can create a right-angle triangle, and then we know that the distance between those 2 points will be the length of the hypotenuse here. How do we get the distance between here and here? How do we get that distance? Well, we can just use the scale. That's a jump of 2. And between here and here is a jump of 4. So to get this distance, I would say, well, c for the hypotenuse, c squared is 4 squared plus 2 squared. And c then is the square root, when I square of 16 plus 4 is 20. So the square root of 20 will be what c is. Don't need your device, ladies. Thanks. Okay, so that would be the distance. There is a distance formula, which is probably what you will use and is given to us in the exam, which is based totally off this Pythagoras' theorem. It is just formalizing that for you. The distance is the square root of x2 minus x1 squared. So the x difference, so the x1, 3 minus 1 squared, plus y2 minus y1 squared. That is the distance formula that is formalizing this process of drawing a right angle triangle. Take the x-coordinates and we'll show we get the same answer doing that. So what do? I have this point 1, 2. I'll write it here. 1, 2 is my first point, and 3 minus 2 is my second point. So this becomes x1, y1, and this is x and y point number 2, x2, y2. I sub this into the distance formula. x2 is 3 here, minus x1. y2 is minus 2, minus y1. 3 minus 1 gives 2. 2 squared is 4. Or well, I just maybe write 2 squared or whatever. This gives 4. And minus 2 minus another 2 is minus 4. Minus 4 squared is 16. So we get the same answer if we do the formula. The formula is just Pythagoras' theorem. So this will be given to you in the formula booklet or the start of your exam. Hi. Do you get all the formulas? No, is the short answer. You get the more difficult ones, but stuff like interior, exterior of a polygon, the angle of that, you're not given that as one example of a formula you're not given, but most formulas you get, yes. There's some small ones that you don't get, like outliers, and or is that IB? Trying to think of another example of a formula you don't get. You don't get y is equal to mx plus c and stuff like that, but you will get this one. Okay, sometimes as well we can be asked for the midpoint between 2 points, so halfway point, midpoint. There is a formula for that. There's a logical process as well. It will be halfway on the x and halfway on the y. The midpoint formula will be add the x 2 points up and divide it by 2 to get the average, and add the 2 y coordinates up and divide by 2 to get the average. So the midpoint between these 2 points, using the same points, would be x1 is 1 plus 3 divided by 2. So 1 plus 3 divided by 2, the x coordinate alone will just be 4 over 2, which is just 2, which makes sense. It's halfway between 1 and 3. The coordinate would be 2. What's halfway between 2 and minus 2? 0, I think. So your 2 minus 2 is your y1, y2, which gives 0. So 2, 0 is the halfway point. Now my scale is clearly, that's the midpoint, halfway on the x, halfway on the y. So add those two up and half them. Okay. I don't know who said it. Oh, right. Okay. So, the distance? Oh, sorry. Okay, so moving along, the next thing we need to look, yeah.
That x2 thing, it wasn't x squared. It was the second x.
Yeah, it's a second x. Yes, second x coordinate. Yeah. Yeah. So they both are x and y coordinates. And to distinguish between the two, you call one x1, y1, and the other x2, y2.
So, wait.
It doesn't matter which one you pick, because it will work no matter what.
3 could be x1.
Yeah, as long as you stick. If you call this one 1, call the other one 1. As in, it can't be x1, y2 in the same. You got to keep it the same way around. Yeah, Ozzy finds this interesting. That's one person anyway. Gradient is where we go next. The gradient of a line or line segment is uphill, downhill. You got two options. It either goes uphill or downhill. Uphill, the gradient will be a positive number. Downhill, the gradient will be a negative number. There's, once again, two ways to find the gradient. You can use rise divided by the run. At any stage, you can create a triangle where we look at how far it goes up over what period of time. So you can see in this example, we've already created the right angle triangle. This has a rise of 4 when it's gone over 2 boxes. So we have a rise here of 4 for going over 2 boxes. So what is the gradient of this line? And be careful. No. Negative 2. Negative 2. Yes, you can see it's going downhill. So it would be negative 2. So you just count the boxes, 4 over 2 in this case, which is 2, but of course it's going downhill, not uphill. Now another way of doing that, once again, is a formula for gradient. Gradient sometimes is called slope. Some people use slope. But the formula is, and it has a letter. What's the letter for slope? Gradient? M. M. Not to be confused with midpoint. Slope has M as its letter. y2 minus y1, so that gives how far it's gone up, over x2 minus x1, how far it's gone over. So it's using the same process as before. Let's see if we get the same answer using this same 2 points. We got 1, 2, and we've got 3 minus 2. We want to find the gradient between those two. Ozzy's going to tell us which one we want to use as number 1, number 2.
I want the bottom one to be number 1.
Okay, so x2, y2. So the first point and the second point. Subbing these in, y2 is 2. Take away y1 is minus 2, so that becomes minus minus 2. x2 is 1. And x1 is minus 3. Or it's 3, but I subtract it because it's minus. Yeah. Hi.
Was there ever be like a case where we can't just find it off the ground?
Yeah, if there's an unknown here, if you're given the gradient and the unknown is in here, it'd be much easier to use the slope formula, but you could use either. Yeah, this is just a shortened version of that. You don't have to draw it, for example. If you're just given the points, you don't have to draw it anymore. Just submit straight and go for it. So I get 2 minus 2, which is 4. My denominator here is minus 2. So 4 divided by minus 2 is also a slope of minus 2. So I get the same answer.
But can you not have a negative? Oh, yeah.
Yeah. So the whole if one part of the fraction is negative, the whole fraction is negative. The whole answer is negative. Okay. Moving along. Hopefully this is just re-entering your brains. Not new.
We learned this.
Yeah, we did.
Apparently some people learned this. I don't know. Maybe you did, maybe you didn't. You can learn it again now. Isn't it fun? Yeah? M is the symbol for gradient. So you don't use G or S, you use M.
So it would be minus 2m.
Nope, M is minus 2. The gradient is minus 2, not the gradient is minus 2m. Then what's M? M all of a sudden becomes a variable.
It's like y equals mx
Right.
We still don't.
Why is it 1 minus? Is it 3 minus?
Ozzy told us to use this as x2 and this as x1.
So you just complicate.
So we got the same answer as long
Yeah.
I use this as the second point and this is the first point.
I use the smarter one.
Nope. I was showing that it won't change anything. The only difference might be if you use them the other way around, the top will be negative and the bottom will be positive. Okay. Special gradients. There are two main ones. Parallel. If lines are parallel, they have equal or the same gradients. If lines are perpendicular, the symbol for perpendicular is this. The symbol for parallel is two straight lines like that, if you weren't sure. The perpendicular lines, what would perpendicular lines have? If they meet perfectly at right angles, what would their gradients do?
They're like the reciprocal.
Yeah, the negative reciprocal, yeah. So that's one way of talking about it. The negative reciprocal. Oh, that's about right. Or you can think about it in more layman's terms, the exact opposite. Slope. So if one slope is, for example, if one slope is 1/3, the perpendicular slope is minus 3/1. Flip it, the reciprocal, and make it negative if it's positive. If it's already negative, make it positive. There's another way of thinking about that. I'll put it up here. That if I multiply the two slopes together, what will I get? The slope of one multiplied by the slope of the second one, and Priyanka already knows it, it is -1. As you can see, if I multiply these two together, I'd get -3/3, which is -1. So that's another way of thinking about it. Kalim is joining the interesting crew. Okay, there are two lines that have weird slopes. This one, a vertical line, and this one, a horizontal line. Which one has a slope of 0?
Vertical's like 4. It's 1. Vertical's 1.
No. A line with gradient 1, for every one box it goes over, goes up 1. So it has this slope, 45 degree. So what is a vertical line? 90 degrees.
So for every one box it goes 0.
It goes 0 over, yes. So it goes one box up for every 0.
That's fine.
So you're dividing by 0, so a vertical line has undefined gradient. Whereas a horizontal line has 0. The gradient is 0. So it's just flat. Now you're not going uphill, downhill, you're just 0. DMAT, thank you. Okay, last thing then. And then you guys get to do some wonderful work, which you always enjoy. The concept of collinear. Does anyone know what this is?
Collinear?
Yeah.
No.
Priyanka knows?
They fall on the same line.
Yeah. Okay. If some points are on the same line, they are collinear. How do I show that points are on the same line? Let me give you 3 points. I have them written down. 1, 1, 6, 9, and 3, 3. Let's call them A, B, and C. How do I know if these are on the same line or not? Test how? Plotting them? Okay. Okay, one way would to be plot them, but that's relying on accuracy and of plotting. You want to prove it, kind of. How do I prove it without plotting? Plotting is like just a logical, yes, visually they look like they're on the same line. And probably you'd be correct 99% of the time, unless they're really far apart. Okay, we're not an equation. We want to use something we've done already, just today.
You pick 2 points.
Yeah.
And then you form equations out of it.
No, I don't need to do that. Something easier than that. Okay, so if I have 3 points, yeah, you think about the gradient. So if I have 3 points, the gradient from here to here has to be the same as here to here. And if I use this same point, getting the gradient here and the gradient here, if I use this point in both of those gradients, they must be on the same line because they join up. And so the gradient doesn't, I know minus and grade, but it doesn't do this, going to the point, and then the next one goes like that. That means they're not on the same line. So what I'll prove is AC and AB must have the same, or let's use this, and CB. Why did I pick C as the middle point? It looks like the middle point, yeah. It would work if I didn't, but I'm looking at AC and CB. I'm looking at the gradients of both. And if they're equal, that means they're on the same line. If they're not equal, that means the gradient after C goes off in a different direction and won't go through 6, 9. Sorry? Looks like C's in the middle, because 1, 6, 3 looks like C's in the middle. It will work no matter what points you pick. As long as if it's only 3 points, you picked at least 1 point twice, which you have to. Okay, so let's do that. Let's get the slope of AC. Use the formula because it's easier than drawing.
What does moth mean?
M is gradient. Yeah. M of. Okay, let's do this quickly. So it's going to be 3 take away 1, y2 take away y1, x2 take away x1 is also 3 take away 1. So the slope of this one, gradient of this one is 2 over 2, which is 1. What's the M of, which is CB? So CB, we got to use these 2 points. So it doesn't matter which way around you do them. We are going to do B as the second point. So y2, 9 take away 3, 6 take away 3. What's my gradient here? 6 over 3. The gradient slope is 2. Are they on the same line? No, these slopes must be the same. The gradients must be the same for them to be. So it's gone at a slope of 1, and then it goes at a slope of 2. So that's not a straight line. Okay. Your homework, which will be due on Thursday, it's written work. You can get started on it now. It's on ManageBack.
Think about it.
Yeah.
Name a number.